All right, for this enrichment lesson, we're going to look at probability. So the probability of an event is the ratio that compares the number of favorable outcomes to the number of possible events. So really, you're looking at the probability of favorable outcomes to possible events and writing it as a simplified fraction. So if you need your factor chart to help you, then have that out. So the probability of an event occurring is going to be between the numbers 0 and 1. So when we look at it's kind of in a chart, 0 probability means that it's absolutely impossible, it cannot happen. Unlikely, an example would be 1 in 6. So it could happen, but there's a very small chance that it would. Even chance, 50-50, like flipping a coin. Likely, 4 in 5. Okay, it's not 100% sure that it's going to happen, but there's a lot more opportunities that will happen than it won't. And then 1 would be, it's absolutely certain, 100% it's going to happen. So let's look at some examples of just kind of basic probability here. So the spinner at the left is spun once. Find the probability of each event. So what is the probability of F? So first thing that we're going to look at is how many F's are there. Well, I look on here, I see 1. So the number of favorable outcomes in my fraction that goes on top is 1. How many possible outcomes are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots on the spinner. So 1 out of 10 of them are F. When it says for 2, what is the probability of D or G? What that means is, okay, what's the probability I'm going to get a D or G? Well, there's 1 D, there's 1 G. That's a total of 2 possible favorable outcomes. And then how many total outcomes did we have again? Well, we already counted that. There were 10 spots on the spinner. And what we want to practice is simplifying. So use your factor chart. 2 and 10 both divide by 2. 2 divided by 2 is 1. 10 divided by 2 is 5. So our simplified probability fraction is 1/5. And then number 3, probability of a vowel. We're talking about A, E, I, O, and U. So how many of those are there on this spinner? We've got I, we've got A, we've got E. So there's 3 vowels out of the 10 possible spots, and that's already simplified. Let's look at some other scenarios. Find the probability of not picking a 7 in a standard deck of cards. So we have a hint. There are 52 cards in each deck, and there's 4 of each number. So keeping that in mind. So that means there's 4 7s. We want to know what the probability of not picking a 7. So if there's 52 cards in a deck, 52 minus 4 equals 48 cards that are not a 7. So the probability of not picking a 7 is going to be 48 out of the 52 possible cards. Then we should be looking at our factor chart to see what 48 and 52 simplify by. 48 and 52 both divide by 4. 48 divided by 4 is 12. 52 divided by 4 is 13. So our simplified fraction probability is 12/13. Number 5. A bag contains 5 blue marbles, 8 red marbles, and 7 green marbles. A marble is picked at random. Find the probability that the marble is red. So let's first think about how many total we have. We have 5 blue plus 8 red plus 7 green marbles in our bag. When I add that up, that gives me 20 total marbles. So we want to know what the probability is that the marble is red. Well, there were 8 red marbles, so the probability is 8 out of the 20 total. Again, we should always double check with our factor chart to see if those simplify. 8 and 20 both divide by 4. 8 divided by 4 is 2. 20 divided by 4 is 5. So our simplified probability fraction is 2/5. Those were simple probability events. Now let's look at some independent probability events. What does that mean? So independent events occur when the outcome of one event does not affect the outcome of the other event. So the probability of two independent events can be found by multiplying the probability of the first event by the probability of the second event. So and means to multiply. So this little picture here is showing us that the probability of A and then B occurring, you do the probability of A times the probability of B. So let's look at what that means. A spinner with 5 equal sections labeled purple, green, red, yellow, and orange, and a 6-sided number cube are used in a game. What is the probability of a player spinning purple and then rolling a 3 or a 4? So we want both of these things occurring. So we've got the part 1, probability of a player spinning purple. So we have a spinner with 5 equal sections, purple, green, red, yellow, and orange. So there's 1 purple section out of 5 total sections. Multiplying it by our second thing. The second thing that we are doing is rolling a 3 or 4 on a standard die. So 3 or 4, there's 2 sides, one side with 3, one side with 4, so 2 total sides out of 6 possible. So what we do here now that we have a fraction is we're going to see if we can simplify anything, either looking at our diagonals or looking across. If you multiply across first, that's fine, or we can simplify first. What I notice is that I look at 2/6 and I realize that those can be simplified. 2 and 6 divide by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So I can just do 1/5 times 1/3 for my answer. On top, 1 times 1 is 1. On the bottom, 5 times 3 is 15. All right, number 7. A game requires players to roll 2 number cubes in order to move the game pieces. The faces of the cubes are labeled 1 through 6. What is the probability of rolling a 2 or 4 on your first number cube and then rolling a 5 on the second number cube? So the first scenario, we're saying probability of a 2 or a 4. Well, that's 2 of the sides out of 6 possible sides. Multiplying it by our second scenario. Second thing is then rolling a 5 on the second die. Well, there's one side that has a 5 out of 6 total possibilities. Before I multiply across, I'm looking at my diagonals or just the fraction itself to see if it simplifies. In this instance, 2 and 6 both divide by 2. So when I do that, 2 divided by 2 is 1. My 6 divided by 2 is 3. When I look at 6 and 1, they only divide by 1. So they stay the same, 6 and 1. And then last step is we multiply these across. 1 times 1 on the top, 6 times 3 on the bottom. All right, number 8. There are 4 oranges, 7 bananas, and 5 apples in a fruit basket. Bobby selects 2 pieces of fruit at random and eats them. What is the probability that he picks an apple, replaces it, and then picks a banana. So this part where it says he selects 2 pieces of fruit at random and eats them, we're not really looking at that actually, because if he ate it, it wouldn't be there anymore. So we're saying he selects 2 pieces of fruit at random. What's the probability that he picks an apple, puts it back in the basket, picks all over again, and then picks a banana? So first, let's think about the total that we have. We have 4 oranges plus 7 bananas plus 5 apples in the fruit basket. When we add that up, we get 16 total fruit. So part 1, what is the probability that he picks an apple? Well, there were 5 apples out of the 16 total, multiplying it by the second pick. So he puts that apple back in, now we're picking again, and he picks a banana. Well, there were 7 bananas out of the 16 total. First thing we should be doing is double checking these diagonals to see if they simplify. When I do, the only thing they divide by is 1. So I'm just going to multiply across. On the top, 5 times 7 is 35. On the bottom, 16 times 16 is 256. And last one. A bag contains 14 red marbles and 10 blue marbles. What is the probability of picking out a red marble, replacing it, then picking a red marble again? So same thing. Let's look at our total. We have 14 red plus 10 blue, which gives us a total of 24. So we're picking out a red marble at first. There are 14 red marbles out of the 24 total. We put that red marble back in, and then we're going to pick again. When we do that, there still are 14 red marbles out of the 24 total. Before I multiply across, we've got some big numbers here. I'm going to check to see if I can simplify. (14) and 24 in this pink scenario, they both divide by 2. When I do that, 14 divided by 2 is 7. 24 divided by 2 is 12. For our yellow diagonal, 24 and 14, those both divide by 2 as well. 24 divided by 2 is 12. 14 divided by 2 is 7. And then I just multiply across. 7 times 7 is 49 over 12 times 12 is 144.